I want to set the stage for you to know how Litron Laboratories, my company, was formed. On a spring evening in 1976, my husband came home from work. I was getting ready to go to my aerobics class. It was a great night, very excited, getting away from 3 little kids. It's fun to do that. He had been teaching biochemistry in the medical school for about 11 years, and I had completed a master's at the U of R, free tuition at that time. It was very nice, just one of the perks back then. And his comment to me as I was going out the door was, "What do you think about starting our own business?" What do I think about it? I think it's a terrible idea. I didn't say this, but going quickly through my mind, I'm going to leave the prestige of being a professor's wife at the University of Rochester to start our own business? I don't think so. But it wasn't out of the clear blue that I heard him, ask me that question. He loved research, he loved teaching, but if you know anything about academia, there's a lot of meetings, and he didn't like that kind of thing. He really loved research and wanted to continue. So I went to class. I, of course, thought about that all during the class time. I'm coming back from class. I had to pull over the side of the road. I sobbed for about 10 minutes and got it out of my system, went home and said, let's do it, let's do it. And I'm certainly glad I did. He passed away in 1994. So he had, from 76 to 94, doing what he loved, and we had all that time together, which I wouldn't have had he been at the university. So I think, even though I was sobbing at the time, I think I made the right decision. Let me see if I can make this slide thing work. You saw that first slide, what your students might be doing. I'm hoping that some of your students will come work at Litron Laboratories somewhere along the way, or apply to any of the other companies that we have here in Rochester. We need well-educated young people, and it's a great place to start out at a small company. When he left the university in 76, it was early. There was no such thing as tech transfer or corporate licensing or anything like that. So the thought was, well, how are we going to do this? I mean, 3 little kids on a university, your first 10 years at the university, you're not making a lot of money. And if you have 3 kids, you certainly are not making a lot of money, and you had to buy a house and cars, and we did with 1 car all those years, but still, we didn't have money to start a company. So we asked the university if we could take our part of the grant into the company. And of course they said no. I mean, no, you can't do that. I mean, the concept wasn't there. There was no understanding that this might be a good thing for a university business relationship. The other guys on the grant, the other professors at the U of R, there were 3 of them, 2 beside my husband, they went to the administration and said, look, he's got great ideas. He can do stuff out there that he can't do at the university. Let him take $50,000 and go try and do what it is he wants to do. And, of course, we had to complete the grant that we were working on, and that is what we worked on for the first 2 years. But as my husband was reading the literature, he saw something in the literature called an Ames test. Do you all know what that is? Raise your hand. Yeah. An Ames test is something in the gene tox world, genetic toxicology world. And it's something that all drugs have to go through. They have to have an Ames test. It's like a first screen. When Pfizer says, oh, I have a new drug, they have to put that drug against an Ames test. It's a bacterial assay. You put your chemical on the plate with certain salmonella strains, put it in an incubator for 2 days, it comes out. If the salmonella has grown to twice background, you have an Ames positive, and that drug cannot go on the market. So he was talking with someone about, he was reading the literature, and he decided that that was probably 78 or 79, he thought that was going to be the wave of the future, that genetic toxicology, that was just a brand new field at that time. He, had the vision that it was going to be what scientists were going to be doing, and he wanted to be part of that. So they were just he and I, so we hired a person, and the three of us learned how to do an Ames test, and waited for the customers to come, and they didn't. And so now what do we do? So another thing that he was very good at, he too was a volunteer, and he established the Brighton Soccer League. And the Brighton Soccer League had 1,000 kids in it and a lot of coaches, and you'd sit on the field and you'd chit-chat with the other coaches. So one day he's chit-chatting on the field with someone from one of those three companies that you mentioned, and this guy says, out of the clear blue, no prelude, nothing, this guy says to him, "Oh, I've been trying to find some place to do an Ames test in town, and I can't find." And he looks at him like, "What?" So that's how we really started going, because then that company sent all their inks, now you know what company it was, all their inks over to us, and we just kept testing them in the Ames test. And that's how we started. It was a great way to get us from the grant money now to making money testing. In 1982, when the small business incentive grants started, those SBIRs, you probably hear about them, and small companies apply for these grants. They're, NIH has it, NASA has them. Everybody has a certain amount of money that they get funded every year, and companies like mine can then go and apply for this money. Now, obviously, you're doing something that they want, but some of them, every once in a while, have like an open subject, and you can apply for it. So sometimes we apply for that. If it's something new that we're just want to start, you have to do it on an open grant. But then sometimes they want to do something in the gene tox arena, and that's when we can go in as well. We actually started building the business in the 80s and 90s with SBIR grants. And we didn't get it the first time. The first time we worked to get a grant, they send you back the comments, and you write it again based on those comments, and then you write it again based on the follow-up comments. But we were able, and these are 100,000, 200,000, sometimes a really big one might be 500,000. Now they're more 750,000, but at the time they were minimal, and you had to pay salaries, you had to buy your equipment, you had to do everything that you would do to get that subject that you proposed to them finished. In the 1990s, if I can do this, oh, wrong way. In the 1990s, we started producing these kits. My husband had come up with this idea of another higher level genetic toxicology test. The Ames test is a lower level. He came up with the idea of doing a micronucleus test. Now, if you remember from biology, or if you teach biology, you remember that a micronucleus is formed when there's an assault on the body. For instance, you may have a very poor diet. You may breathe all kinds of terrible things out of the environment. Whatever you do, you normally will have 4 micronuclei per 1,000 red blood cells in your body. But if you start assaulting your body with all kinds of things, that micronucleus level, which is a chromosome break, that's what happens. You get a little piece of micronucleus form. If you start assaulting your body with all kinds of things, that micronucleus level will increase. And as your micronucleus level increases, so does your propensity for cancer. So you may go from 4 per 1,000, 8, 12. We're doing the research now. We don't know at what point cancer is going to form. We're still working on that, but we do know from animal studies that that is a reality. So we can't tell you don't eat this or don't eat that yet, but probably in another 10 years we will be able to tell you that, and we will be able to tell you if your micronucleus level goes up to 20, you know, you're heading for real danger. So it was a very good test. We've just started the human studies about a year ago, but all chemicals, all new drugs have to do this. It's a requirement, the FDA and all the agencies. You can't get a drug or any other chemical on the market, as well as a medical device. You can't get a medical device on the market unless it's gone through this micronucleus test. And the micronucleus test is an in vivo test, so it's done in an animal. And what we do, we take the new drug in various concentrations, put it into the animals, then in 48 hours or 72 hours, take a blood sample, put it on a flow cytometer, find out how many micronuclei there are. And the reason we went to flow cytometry, I don't know if you've ever counted cells under a microscope. You probably all have. It is the most boring of the boring things you do in a lab. It's just tedious and time consuming. I'm sure you all teach your students to do it because it is necessary, but it is boring. So when Andrew my husband, when he came up with this new system of doing a micronucleus test that had been for a decade, it was counting on slides. And you would count 2,000 cells to figure out how many micronuclei there were. Well, when we went to flow cytometry, now you can count 20,000, 100,000, a million in some cases, cells over the course of minutes, where a slide would take you sometimes an hour. I mean, it's just so much more sensitive, robust, and accurate. So we're very happy with our microflow kits. We sell them a lot. You can see when we started, I don't know how this laser printer works, but when we started selling in 2000, this represented 18 kits. And through the years, this represents 600 kits. So they're sold for a couple of $1,000s, and mostly pharmaceutical companies are buying them. CROs, contract research organizations, also are buying them, and they're used to check out the new stuff that's going on the market. Nobody wants to be sued. Nobody, someday when we are able to say what a person's micronucleus level is, they may be able to trace back and say, well, it's the high blood pressure drug I took that's causing this, or whatever. Aspirin, who knows? Who knows? We don't know what we're doing to our bodies, but maybe someday we will know. Our overriding goal has been and continues to be, how can we improve human health? A lot of the companies that Jim mentioned in Rochester, and this is kind of a pet peeve of just me, it doesn't have anything to do with all these other companies. Pet peeve of mine is the people who take venture capital. They take people, and the people who are given this venture capital are usually pretty well heeled, and they know they're taking a chance. But they take a chance, they give money to a new company starting up. The new company starting up, those CEOs pay themselves very well because they know they may not be here in 5 years. With the company that we started, we really did it on a shoestring. So now I'm thinking, in a way, I don't like the idea of spending other people's money in a carefree kind of way. And I'm kind of glad we did, because since I've been in Rochester, dozens of small companies have folded. And we have been able to slowly build a company. Now, that's not to say that in 10 more years, when I'm really at the point of thinking about retiring, I might not sell. I probably will sell. But it's not how I built the company. I didn't build it with other people's money, and I'm kind of proud about that. This is what improving human health is what my very small staff of 15 people, it's what they get up every day and think about. They don't think about, is she going to give me a raise? They're thinking about helping human health. And that's a very nice atmosphere to work in. It makes me want to get up every day and go to work. No problem. All right, now let's talk about the nitty-gritty of why you're here. This is the kit contents. And that's just one of 25 different kits. All that stuff has to go into a kit. There has to be somebody that prepares all those solutions. There has to be somebody that makes all the labels. There has to be somebody that QCs everything. So you think, how can a 15-person company be a manufacturing company? Well, we put these kits together right in our own lab. And we have, these 15 people are so well versed. They all are biologists. Well, there's one chemist, but you know, they all have that background. I could not trust anyone to do the things and to send it to pharmaceutical companies where they're going to do a test based on what's in this kit. I couldn't just say, I'm going to take somebody off the street who just wants a job and let them prepare these kits. So when you're talking to your students, there are a million different jobs in biology. It's not just research. It's not just testing. There's a ton of things. The shipping person that does the shipping, she has to speak with the clients on the phone. She has to know all about the things that are going into the kit. When they ask her, the green labeled thing was leaking, or the green labeled thing wasn't as cold as it should be, she has to be able to say to them, I'll send you a new one because it's compromised in some way. She has to have some background. So I sometimes do hear biology teachers talking to their students only about research. And I'm saying there are a ton of other ways that you can use your degree in a small manufacturing company. And it's worth mentioning that these kits are going to not only contract research organizations, CROs, who are testing drugs for big companies, but it's also going to the drug company themselves or to the university professor who also is working on a grant, has a limited amount of money. If he orders a kit and there's not good material in it, he's not going to know if it's the cause of the kit or the cause of his thing that he's working on. It's got to be precise, and the people that are preparing it have to know that everything in it. And we QC, quality control, everything that we do, from the labels to the antibodies that we prepare. We ship to a lot of places, all those states and all those countries. We've been to many, probably half of those countries. We do training as well. So we recently have been to Croatia and Japan. France, of course, and Germany and England are common, as well as Canada. But it's kind of interesting to us. We have more customers out of the country than in the country, which I'll talk about a little bit later. Our kit supervisor was telling me about, just yesterday, she was telling me about a $30,000 shipment, that because of a kit component, methanol, which we now don't use because it did cause problems, but this methanol, a pilot happened to see it on the shipping box, and he says, I'm not taking that. I don't want methanol on my plane, because it goes into the cargo of various planes. So it was held up there, then it was held up at customs, and so the shipment of micronucleus kits didn't get to the customer that it was supposed to get to. So that customer was obviously upset. It, it broke into their experiments, the things that they wanted to do. And if the labeling were correct, this was before we got into all the QC labeling. If the labeling were correct, it would have said 0.0001 ml of methanol, which is not considered a dangerous good, but it just said methanol, dangerous good. So, you can't blame the pilot, but yet it's making the point that I'm trying to tell you, that people have to be educated who are sending out these kits. It just can't be a shipper. Superior communication skills are also something that we talk about at Lightron. These are various people at Lightron doing jobs, researchers on the upper left, people preparing kit materials on the right. In the middle, people doing labeling, a quality control person all the way in the back. People looking up regulations, because not only do they have to know what the regulations to ship are, they have to know the customs rules in the other countries. They have to know what the FDA in this country is deciding. So again, the educational level has to be such that they pick up the phone, they call the country, they get the materials that they need in order to make it legal, because as we all know, ignorance of the law is no excuse. For 30 years, we had no regulatory interaction. We thought we were riding a high wave, because we'd heard all kinds of things about when the FDA comes to inspect you. So it was completely a shock to me to go answer the door one day, and the guy puts his FDA badge in front of me and says, "I'm here to inspect you." Oh my gosh. Well, we thought we were following everything, and so, you let them in, and you have your master list, and you have your, where everything has been checked and rechecked and double-checked, and you have a quality control person who is part-time, and she's doing lab work the rest of the time. Well, after that, we had a quality control person full-time. That's about the best way I can describe it to you. We got a warning letter, and that warning letter had 15 items in it that they considered to be egregious enough to write us up for it. We made those corrections. We've had 4 or 5 inspections since then, and we're validated that we made the corrections, and we're absolutely right on board now. But again, that's another very important area of biology. This gal has to go every second year, just to go to the quality assurance convention, wherever they hold it. And I have to go once every 5 years. Management has to know what it is that I'm expecting of her. So it's a very good field of biology, this quality assurance. They take care of each other. They call each other up and say, I have this problem or that problem. It's well thought of in all the drug companies. They really have a lot of respect for their quality control people. So that too is a very good career out of biology. What we had to do to go from having problems to absolutely not having any is complete something called a gap analysis. It's kind of a business term, but what they did was they went through, our quality control person went through every process that we have to make these kits and figured out what it was that she needed to do and how many times she needed to inspect the preparation of the reagents, how many times she needs to check the labels. Everything has to be checked. So we feel now that we have a really good handle on all the quality assurance stuff. And it's vital. I mean, we're a GLP lab, good laboratory practice lab, and you have to do it a certain way. At Lightron, this gal who's up there on the left, she's our customer service person. She also is head of the microflow analysis team, and she answers every phone call that comes in with a question. So it's not as if you're calling Kodak and trying to get to somebody there that knows something about the product. At Lightron, we answer the phone unless we have two lines, so if they're both busy, you might not get an answer. But pretty much we answer the phone. Somebody who has bought one of the, they spent money on these kits. They want to know something about it. They can talk to a person that absolutely runs the same thing that they're trying to do every single day. Dorothea was telling me about a story about someone who kept sending her images. What happens is, on a flow cytometer, if you've seen, you get these boxes and there's dots in the 4 boxes, and somehow you interpret that. They know how to interpret it, and if the boxes are a certain way or if the dots are a certain way, Dorothea can tell if the sample has been warmed, if perhaps one of the reagents is warm and not able to be used in the process. For a long while, we were sending things on dry ice. We now have a long-term storage solution that we don't need to do that, but we still have to send on different temperatures. So she can interpret, when she gets these images from the flow cytometer, she can interpret whether or not it's a good run. And this person kept calling and kept calling and kept calling. Finally, what came to be, we used to send tubes with the kits. After this call, we decided to figure something else out. Now we tell them exactly what tube to buy, because what we found from that phone call and those 5 times this guy called was that he was using a tube, just any tube from his lab. Well, I don't know about your lab, but I know my lab, I don't want to use any old tube in my lab. You don't know what was in that tube. You don't know what went before. And so now we tell them, you buy from XYZ company to go along with this kit. They come sterile, they come covered, they come in a way that's good. And so now we solve that problem. But there's always something. Somebody will do something that you think. One of the main things, you have to keep the blood samples in a minus 80-degree freezer. So right now you're thinking, oh, I know where there's a minus 80-degree freezer. I bet it's an upright wherever you're thinking about it, and you can't use an upright. It has to be a chest freezer. People try and try and try to use an upright minus 80 freezer. You're in and out of that thing all day long. That temperature is changing, and those blood samples have to be kept at minus 80. So even in the chest freezers, and we have 5 or 6 of them, has to go all the way in the bottom of those freezers when the blood samples come in. And we, if people send us blood samples, because we have 2 ways, they can either buy a kit that they do it in their own lab, or they can send the blood samples to us. If they send the blood samples to us, we put them way in the bottom of the freezer, we keep it there a day or 2, and then we have them on the flow cytometer. We don't want to take any chances on compromising or warming those samples. So who uses these kits? You can see there, pharmaceutical companies are probably the main users. And way down, contract research organizations are probably next main. But people, chemical people, tobacco people, government. The tobacco people, of course, they're interested in seeing, all these light cigarettes they're trying to get. Well, they put their mice through breathing all that stuff, and then they send the blood and say, did we cause chromosome breaks? Did we cause micronuclei to form or not? So that's just the kind of things that are going on. The clinical trials is where we think it's going to boom in a couple of years, because clinical trials, it's only a couple of drops of blood you need to do this assay. So it would behoove them to take advantage of that when they do all these other tests. And, they have to do not a million, but, they have to do probably 3 dozen different tests. And why not take a drop of blood and find out if you're increasing micronuclei? And that might be just the perfect place to do it, because the person's, the first phase, it's 15 people taking a drug that they've never used on a human before. That would be a perfect place to do it, because, if you were going to see something, if it's, going to cause micronuclei, you might be able to see it right then and stop it at the early stage of the clinical trials. In 1986, the worst nuclear accident in the world's history occurred in Chernobyl, Ukraine. It sent plumes of radioactivity throughout Ukraine as well as the Western Soviet Union and Europe. It resulted in the evacuation and resettlement of 336,000 people. Our client, a professor at Texas Tech, was asked to determine whether people could safely go back to their homes in that area. Now, granted, they have radiation monitors throughout that area, so why would she think of using a kit like this? Well, it's different. You can have a radiation detection device there, but what matters is when it goes through a biological system. And so what she has done is she's put mice and rats in that area, marked, of course, and she goes back and tests whether or not those mice and rats are still that radiation going through them. And so the government might say, oh yeah, we're not getting any detection, no detection of radiation in that area, sure we can move back. But going through a biological system, as you know, is the true test of whether or not something is going to be harmful. And she's published her materials, and it's really a great story. It's not safe to go back yet, so that's probably not a surprise. She hopes in time to be able to answer the question, and she hopes in time to be able to say that, yeah, it is safe to go back. Mice and rats are not absorbing any more radiation. It's at such a low level. Another example of scientists using our microflow kits would be a study conducted relative to the safety of HIV/AIDS. Women who are expecting babies and have the HIV/AIDS virus are given an AZT cocktail. It's a wonderful drug, and it stops the transmission of HIV/AIDS from the mother to the fetus. The fetuses do not get, if they keep this good amount of medication, if they keep up with what they're supposed to be doing, their babies will not get HIV/AIDS. So someone at the FDA wanted to know, okay, but what is the AZT doing to these fetuses? It may be fine to stop the transmission, but what is it doing to the fetus? That story is not as good a story as I would like to report to you. They can't stop giving AZT because they have no other drug to stop the transmission. So it indeed is passed to the fetus, the AZT, and all the effects that it has. And it does cause chromosome breaks in those fetuses. And what we're hoping is that over time, all of these people are on notice that, you know, their child has been delivered this regimen of AZT medication. And what they're hoping is that their physicians, their pediatricians, now knowing this, will keep a very close eye, and if there's any sign of cancer, and they have to think about that, maybe they have a leg up and they'll be able to do something very early to those children. It's a sad thing. I hope someday we're going to be able to say, yeah, we can tell that it's transmitted, and yet we can give them this other drug that erases it. So we'll see. We'll see what happens. As you probably can tell, I'm pretty excited about what goes on at Lightron. It's a fun place to work. I just enjoy listening to everything that goes on every day, and there's always something new. There's another generation of assays that we're working on that are going to be fun. It's another mutation assay, and we're getting a lot of interest from scientists all over the world. But that brings me to what I sort of alluded to a little while ago. As you know, manufacturing jobs have been fleeing to China. That's not a secret. In a World Trade Organization headline recently, the headline was, "As China rises, America tumbles." And for the past 10 years, China's economy has been rising. It's grown 4 times faster than the US economy, and it all has to do with manufacturing. Because of massive trade deficits with China, every U.S. manufacturing sector has lost a substantial portion of its economy and its jobs. A once incomparable and dynamic U.S. supply chain of manufactured goods is clearly weakened and shifting to China. And one of the things, like I started to say before, we have so many more customers in Europe, Asia, than we do in the United States. I mean, we still have the big drug companies, but it's just amazing to me that elsewhere there's more interest in this product than right here in the United States. I don't know if that's indicative of anything. I'm just telling you what I've noticed. I think we as educators have to be aware of all this political stuff that's going on, and we have to be willing to talk about what we know about. We know the science. We have to share it with our public officials. They too have to become aware, and they aren't aware for the most part. They may, they're now talking about health care, and it's a 1,000-page. I think you probably saying 1 or 2 words to your local congressperson about health care, or whatever the subject is, probably means more than them sitting there reading that 1,000-page, or because they're never going to do that. Another indication of, am I going to push this? These are the places that we've been to recently. It's a global reach kind of thing. Many of the people who work in my lab are the ones that are going to these places. That's another thing to tell your students. There's a lot of opportunity for travel if you're in the right field. Years ago, when you said to someone that they were going into biomanufacturing, they imagined themselves sitting on a line doing the same thing over and over and over again. But that's not the way it is in biomanufacturing anymore. Biomanufacturing in the big companies, of course, is probably still that way. There are those kind of places. But biomanufacturing at Lightron has everything in it, and it's all contained in one lab. It's exciting. It's fun. I feel blessed to have been able to do this. I am thankful I said, let's go for it, way back in 1976 when my husband suggested. I feel like we are improving human health. We are stopping the harmful drugs from getting to the market. And my hope is that you will convey this sense of excitement about what's going on in this dynamic career path for your students. Thank you for your attention. If you have a question, I'd be happy to try and answer it.
And a reminder, if you could get the handout on the slide.
Oh, and we do have handouts here. We copied a list that was printed back in '04, I think, of attributes that your students might want to have to, apply to a company. I think I bolded the ones that I personally feel, I bolded 5 or 6 of them that I personally feel are important. And there's a piece of chocolate up there for you, too. So, sir.
Hang on. I got the mic.
Thank you. Are there comparable tests in the market?
I'm sorry?
Comparable tests like yours in the market?
Well, the great thing is we had a monopoly on it for a while. There was another company that came out with something like this, and they came to one meeting and presented their material, and we've never seen them since. So I don't know. I don't know if they gave up or what, but we're happy we don't see them at the meetings anymore. Jim?
I think I'm one up on you. I got the mic, so yeah. A question I had, and I can't believe I never asked you this before, but with other applications that you might be developing, would there be any reason why you would have to manufacture your kits under GMP regulations?
Yes, and we're working on that right now. What we did was we got a grant from Rochester Works, and our quality assurance person is not only, we're a good laboratory practice lab, GLP lab, now she's making us a GMP lab as well. And there are, different things that have to be. You can still manufacture a product. You don't have to be a GMP lab to do it. But if you go into human kits, selling them abroad especially, you have to be a GMP lab. And so that's what we're working on now.
I wondered how widespread this testing is industry-wide on the clinical side, and what requirements there are for this or other comparable testings.
There is no requirement right now, which is sad because it can give information. But let me tell you this. Remember that graph I put up there with all the green lines and sold 18 and now we're sold 600? Those are all mouse and rat kits. Those are all kits that the drug companies are putting the drug into the animal, and with all the other testing that they're doing, they're taking a couple of drops of blood and they're doing the micronucleus analysis on it. So I'm thinking the same things probably from the clinical end. It's going to take a while before everybody understands. And we're going to the FDA all the time trying to get them to move on it, but they run at their own pace too.
So is the idea basically to what I'd like is every time I go for a yearly checkup, they would take a drop of blood from me and check my blood.
Exactly. I would love that to be.
And maybe Europe is going in that direction?
I don't know. They're buying a lot of kits, so it could be. Mm-hmm. And when we get this GMP, then we're able to send human kits to Europe. Now they can only send us the blood. We can't send the whole kit yet. It's part of the regulatory thing. I'm not quite sure what the rationale is. But now they can send us the blood. If we send them a kit to gather the blood, they can send it to us to analyze. But we can't send it to them and let them do it there. So I would love it to be, but that's probably 20 years out. I hope not, but the reality of what happened to these in vivo microflow kits, I think it just takes time.
A couple of weeks ago, I was in Scottsdale and visited Biodesign Labs, and basically they're doing cord blood testing from Boston of two sets of babies. One that has no contaminations with chlorinated hydrocarbons and brominated hydrocarbons, and the other cord blood does. And they're looking at all the different proteins in the blood, but they really should be using your kit as well to test. You
write to them and tell them that we exist.
Okay.
Biodesign in Scottsdale. Okay. Yeah?
No, I have the microphone.
Oh.
Sorry. How do the results of the Ames tests compare with what you get with the micronuclei?
Many times this is how the operation goes. If you get an Ames positive, it's almost like, oh, shoot. We're not going to be able to put that drug on the market. But if you do the in vivo assay that this is, and it's a negative, it overrides it because it's a higher level. So it might have been a false positive in the Ames test. But if it's in vivo, they don't consider it, if you don't get any results, they consider that real. So.
And then do you know anything about the genetic information contained in the micronuclei? And are they generated randomly, or are you getting specific regions?
The only thing that we absolutely know is when the daughter cells are breaking, and part of the nucleus goes to each. These micronuclei are in between. They're in the cytoplasm. They're not within the nuclear material. So we're counting all those little specks that are left behind or broken off. It's fascinating. The guy who did this, 20 years ago, first guy that saw it. It's like, to me, it's like when Lewis and Clark went and they for the first time saw the West. That's the way I feel. He must have been so excited to see those little pieces and make a connection. Oh, you only get little pieces when something has compromised the blood. It must have been fun. Must have been fun to discover that. These are FDA-approved kits. They are, like I said, we finally got into the FDA Red Book, and they said, okay, it's okay to use these. Now what we're trying to do is to get them to say, it's okay to use, and that's rat and mouse, it's okay to use them for human. That's what we're working on now. And we sent, no kidding, see these binders you have? The binder was that thick of, data and papers and all kinds of information, trying to get them to understand the importance of this, now using it for human blood. We're working hard.
Okay, so it's not
for humans, no.
It's very interesting, and my question is, in the Ames test, which tests for mutagens,
right.
Not all mutagens are carcinogens.
That's absolutely true.
And I'm curious with these micronuclei, what's the research showing that they're even related to carcinogenic activity, or is there a dose response for these, or is it some non-specific, regulation in the cell to even repair DNA damage?
Right.
I guess my question is, how relevant is it?
Right. It's relevant enough for the FDA to have said to us, we want to be able to do this, you have to send us the material. They ask us to present the material to them. It was really, we were thinking, well, maybe we would just have this in our lab. If people wanted to have a test, we would do it. But we wouldn't have kits or anything like that. With encouragement from them, but even with encouragement for them, we have to then prepare this binder full of material, send it to them. They're saying to us, look, we can't, we'll answer you in 60 days. 60 days was last Friday. We're all sitting there waiting for the phone to ring for them to tell us what is going to happen, but they haven't as yet. They haven't as yet. If you Google micronuclei, you will find a wealth of information and lots of answers to your question. What was that? Oh, was it? Yay! Who's first and second?
Micronuclear RBCs. One is there are two studies: induction and time-dependent accumulation of micronuclei, and effect of pulse electromagnetic fields in the frequencies of micronuclei.
Nice, nice.
And third is Lightron, background on micronucleus test.
Great, great. I think what makes it, and why Lightron is considered to be the micronucleus company, is because we have decided to kind of concentrate on this gene tox area, where as a company like Pfizer, they can't concentrate on something like this. They have to spread their research through many, many areas. And we have decided gene tox is it for us. We started with Ames. We don't do Ames anymore. We do micronuclei, and then the next generation of genetic toxicology assays that we're going to be doing.
Time for one more.
Can you just share with us a little bit about what your future ideas are? I mean, just,
okay,
sketchy
so
as they might be.
I'm gonna give you something to Google. And you're going to say, what? PIG-A, P-I-G-A, small P-I-G-A. That's going to be, if you know that, you're going to be in the forefront of the gene tox arena that's coming up now. And what we've done is we've come up with a new mutation assay that we hope is going to take the place of it'll never take the place of Ames, never, because Ames is solid, it's been there a while and whatnot. But if you get an Ames positive, you might want to do a PIG-A. And the scientist, I wish he was here to explain it to you, the gene had to do with something having to do with a sleep imbalance, and he was at a meeting one day and he heard about this gene and he said, I'm going to investigate it. So he investigated it, said, you know what, I think I could make a kit for this. He pulled together the materials for a kit. We were at a meeting. Japan said, we need a new mutation assay. We want to be part of this thing. So he's got, I think he's got 10 countries now, all being fed their prototype kits, beta kits. They all have these pig A kits, and then they'll publish the material, and then after that, we'll be able to sell them because we'll have all the data validating the pig A mutation assay.
Well, as a reminder, before you leave, before we thank Carol, if you could come down here, grab your little
Chocolate.
treats and some handouts, and don't forget the vendor show where that's different locations. So thank you, Carol.
Oh, thank you. Thank you all. I appreciate it. Very nice.